Welcome to the final part, the part 13 of the Spring Boot microservices tutorial series. So in this part, we will be mainly concentrating on Dockerizing our application and then deploying the application to the Kubernetes cluster. I will cover all the services and the necessary infrastructure, and will show you how to create the Kubernetes manifest file and then manage all the manifest file using Kubernetes. So without any further delay, let's start the video. So before starting the video, a small disclaimer that this is a practical course, I cannot cover the basics of Kubernetes in the same video. So that's why I suggest you to refer to a beginner level Kubernetes tutorial. So once you have the necessary basics of Kubernetes, like what is a pod, what is a deployment, what is a service, and what are config maps, etc. So just if you understand the basic workloads of Kubernetes, then you are ready to start with this practical tutorial. So please do this favor, learn the basics of the Kubernetes, and then you can start watching this tutorial so that it will make much more sense for you. Alright, so now let's go further and dive into the tutorial. Alright, so in the previous videos, we saw that I've developed each service as an individual microservice, as an individual repository. So what I did here is I created one parent project called as Spring Boot 3 Microservices course, and I embedded all the services and components we are using inside this parent project. So you can see that we have this API gateway, the front end, inventory service, all the services are embedded inside one parent project here. So what you can do is you can directly check out this GitHub project, and to follow along, you can check out the initial branch. So if I go to the initial branch here, you can see that this is in the same state as in the part 12 of this tutorial. So everything is up to date. So we have this front end service and also the other services which are in line with part 12 of this tutorial series. So whatever changes I'm doing, make sure to first check out this initial branch and then start coding along with me, so that you can gradually work your way up to the final part, which is you can find the final part of this source code in the master branch. So if I check out the master branch, you can see that there is a folder called as key8s, which contains all the necessary manifest files and configuration for the Kubernetes. So now I already have this project in my local, and I'm on the initial branch. So the first thing I'm going to do here is to Dockerize our services, right? So we have our Docker folder. So we have our Docker compose file. Here you can see that we have all our infrastructures like MongoDB, MySQL, Zookeeper, Kafka, and all the infrastructure we have created the Docker compose file for it. But the actual services like the product service, order, notification, inventory service, these 4 services, and also of course the API gateway, for these 4 services did not yet create the Docker file and the Docker images, right? So for that, what we have to do, so let's do that right now. So basically we can create a Docker image for a project using 2 ways, right? The first one is using a Docker file, where you add a Docker file inside the root project. So like, for example, I can create a new file called as Docker file, and I can write out all the instructions of how to create this Docker image right inside the Docker file. And when I run the docker build command, it will take the instructions which is present inside this Docker file, and it will create the Docker image for us, right? I hope you are familiar with this. So this is one way of creating a Docker image. And another way is by using something called as cloud native build packs. So if you Google for cloud native build packs, you can see this buildpacks.io website. So if you click on this, you can see that the cloud native build packs is a way of creating Docker images automatically from your source code itself, right? So you can see that the cloud native build packs transform your application source code into container images that can run on any cloud. So this is a industry standard way to create Docker images out of your source code. So one advantage of using cloud native build packs is you don't need to manually maintain the Docker files, right? So if your Docker image is straightforward, you don't need to, you can just rely on the cloud native build packs to generate the Docker image instead of writing and maintaining this Docker file. You can make use of the cloud native build packs. That will make our life far more easier. to generate the Docker images. So to use this cloud native build packs, we can make use of the Spring Boot Maven plugin, which provides out of the box support for the cloud native build packs. So we will be using Spring Boot Maven plugin to generate the Docker images of all our services. So let's go ahead and do that now. Before that, I'm just going to delete this Docker file. I don't need this anymore. What I'm going to do now is I'm going to the pom.xml on the Spring Boot 3 microservices root project, and I'm going to scroll down. And here you will see that there is a plugin called as Spring Boot Maven plugin. So this is coming out of the box from the Spring Boot starter itself, out of the box from the Spring Boot starter project itself when we create it from the start.spring.io website. And you already have the command to build the Docker image by, if you go to the Maven, if you click on the Maven icon, and if you just expand the Spring Boot 3 microservices and then go to the plugins, and you have the plugin called as Spring Boot, just expand this plugin and you see different goals which the Spring Boot Maven plugin is providing us. So one of the goals, the first one is the Spring Boot build image. So what this image will do is it will automatically generate the Docker image for us. So if I try to double click on this Spring Boot build image, it will identify the Spring Boot project, all the projects, and it will try to run the Spring Boot build image goal, right? So you can see that it is automatically building the image for the API gateway right now as we speak, and it is pulling a builder image called as builder Jammy base, which is coming from the Paketo build packs. And using this base image, it is trying to create a Docker container for Docker image for the API gateway service, right? So this is how the build image can be created automatically. So as you can see that I did not add any other configuration. Everything is present inside our Spring Boot project itself. So you don't need to create any other external Docker files or anything else to create the Docker images. So I'm going to stop this for now, and we'll come back to this later. So we need to do some small change here because I'm running this project inside an Apple machine. So for that, if you want to run this run the build packs using an Apple machine, you need to use a custom image so that you don't face any configuration issues. So for example, you can see that by default we are using this builder Jammy base image to create the container images, to create the Docker images for our API, for our services. But instead of this builder Jammy base, what I want to do is I want to use a different image. To use the different image, I'm going to go inside the configuration section of the Spring Boot Maven plugin, and I'm going to type a tag called as image, and inside this image I'm going to use a builder called as Doshawn/builder tiny. So this builder is compatible with Apple devices when we are using M1 chip, M1 silicon chip, or M3 or M1, M2 or M3 silicon chips. Make sure to add this particular builder so that Docker image which is created is compatible and runnable on your Apple machine. So after adding that, we need to add some other configuration, we need to also add the name of the Docker images which we want to create. So we don't want our Docker images just to have some random names. So it's better to have some predefined names. So for that, I'm going to add a name attribute inside the image tag, and inside the name attribute, I'm going to add my username of the Docker Hub account, and I want to have this as new $project.artifact.id. So the $project.artifact.id is referring to the artifact ID of the project which is being built. So if I click on this, you can see that for this pom.xml, the artifact ID is Spring Boot 3 microservices. So if I go to the API gateway, the pom.xml, the artifact ID would be the API gateway. So I have to make sure that the Docker image I'm creating for each project is using this particular format for the name. So this is the username of my Docker Hub account, and after that I have the slash, and then this is going to be new the project artifact ID. So for example, for the API gateway, this is going to be my username / new API gateway. This would be the name of the Docker image I'm going to build. right? So you may be asking why there is a prefix called as new, because I already have a Docker image with the same name called as API Gateway, because I've created it in the previous Spring Boot microservices tutorial. So I just want to not override this particular image. That's why I added this prefix called as new to the Docker image. All right. So after adding this particular configuration, I also want to push this Docker image to the Docker Hub. So for that, I need to add another tag called as publish true. So what this will do is it will try to publish, not only build your Docker image for all the projects, but it will also try to push this Docker image to the Docker Hub, right? So the next step, so the next question is, of course, if you try to push this Docker image to the Docker Hub, we have to also provide the credentials to the Docker Hub. So how to do that? So we can do that by creating a different tag here called as Docker. And inside this, we can provide the publisher registry information. So you can see that GitHub Copilot is already suggesting me some configuration here. So I'm going to use this. So the username, the GitHub Copilot got it correct, but the password is not this one, of course. And I can also remove the URL because I can use the default registry URL. So I just need the username and the password. So to get the password, you have to open the Docker Hub. So I'm inside the hub.docker.com portal, and I've logged in with my Docker account. And after logging into the Docker account, you can see that we have the repositories of the Docker registries, the Docker images, which we have in your account. So if you don't have any Docker images pushed to the Docker account, so you don't see anything here, of course. So what we have to do is we have to go to the profile to the top right side corner and click on account settings. And here we have something called as personal access token. So click on this personal access tokens, and you can generate a new access token. So you can just put a description, something called as token, and then we need to have a read, write, and delete permission here. After selecting this option, make sure to click on generate. It will then show you the access token you want to use. Make sure to copy it and then save it for the future, because we want to use it, of course, inside our project. So after generating the token, what you can do is you have to use this inside this password tag. I would not suggest you to simply copy this particular token inside the pom.xml, because that is not so good. So we should not store any kind of secrets inside our source code, especially the sensitive secrets like the secrets for Docker Hub account. So as an alternative, what I would suggest is to create a property inside the properties tag called as Docker password, and let's refer this particular property inside the password tag. So for that I'm going to type $ curly braces, and I'm going to reference to the Docker password variable. So if I click on this, control click on this Docker password, so it's taking me to this Docker password property, and we have to somehow override this particular password, this property with we have to provide the password to this particular property while building our Spring Boot image. For that, I'm going to type in another placeholder called Docker password. So whenever you want to run this build, you can use the command maven spring boot. So let me highlight this. So whenever you want to run the build, you can run the command maven spring boot build image, and you can provide the Docker password. So in this case, you will be using your Docker Hub token here. So make sure to run this particular command, and then it will start the build. I did all this configuration. So let's go to let's make sure that to load the Maven changes. And once it is done, let's run the Maven build command. So I already have the Maven build command with me. So I'm just going to run this. And you can see that it's trying to build the Docker image for all the projects. So I will come back to you once all the images are successfully built and deployed to the Docker Hub. All right, so you can see that, so the build is now successful, and you can see that the total time it took is around 1 minute 45 seconds. So this is on my machine. So if you're maybe on your machine, it can be faster than 1 minute 45 seconds, or maybe it can take much more time. And then once this is done, you are now ready to dive into the Kubernetes world, because now we have the Docker images, and these Docker images should also be pushed into the Docker Hub. So let's open the Docker Hub, and if you go to the repositories, you can see that the image is pushed 1 minute ago. 2 minutes ago, you can see that the push is successful. That means our Spring Boot Maven plugin is able to successfully build the Docker images and also push the Docker images to the Docker Hub. So the next step would be to dive into Kubernetes, as I said. So for that, we need to first create a local Kubernetes cluster. So let's see how to do that. So to create a local Kubernetes cluster, the tool I'm going to use is called as Kind. So as you can see here, Kind is a tool for running local Kubernetes cluster using Docker container nodes. So this is a very widely used local cluster for Kubernetes. You may have heard other options like Minikube, and also Docker itself comes with its own Kubernetes cluster. So if you open the Docker dashboard, so let me open the Docker dashboard here. You pull up to the screen, and then you can see that if you go to the settings tab onto the top right side corner, and you have this option called as Kubernetes, and if you click on enable Kubernetes, the Docker engine will start a Kubernetes cluster. So you don't need to install anything else, but I'm choosing Kind because it is what I observed is like it's less resource intensive, and that's why I'm using Kind cluster. You can also use any other cluster like Minikube and also the Docker Kubernetes engine. It's your wish, but in this tutorial, I'm going to use Kind to create the local Kubernetes cluster. So to install Kind, you can see that the prerequisite are you need to have Go installed. At least the 1.16 version is the minimum. And after that, of course, as you have Docker, all you need to do is you have to run the command go install and the package name of Kind. And once this is done, the Kind package will be installed to your machine. And after that, all we need to do is to type the command kind create cluster. So once you run this command, it will automatically create the Kind cluster. So if you just scroll down, you can see that in the usage section, you can create the cluster by typing the Kind create cluster, and you can also delete your cluster using Kind delete cluster. So to create the Kind cluster, we need some additional configuration. So for that, I'm going to go to the configuration tab here, and I'm going to click on this extra port mappings section. So what I want to do here is I want to create a Kind cluster, the local Kubernetes cluster, by exposing the port 80. So I want to expose the port 80 to the Kubernetes cluster to run the Kubernetes cluster on this port, right? So for that, I just want to copy this particular YAML file by clicking on this copy link here, so that it will copy this contents into the clipboard. And I'm going to, on the root project, I'm going to right click and click on new directory called as K8s. And inside this K8s, I'm going to create another directory called as Kind. And here I'm going to right click and create a new file called as kindconfig.yaml. Right? And inside this YAML file, I'm going to paste this particular content here. So you can see that you are using a Kind cluster with an API version of v1 alpha 4. And here inside this configuration, we are assigning the configuration of our nodes, which the Kubernetes cluster, the Kind Kubernetes cluster will create for us. So for this node, for the nodes, we want to create a control plane with this particular extra mappings, where the mappings of the Kubernetes cluster port 80 is mapped to the host port 80. Right, and this is listening to the listen address. We have set it as 127.0.0.1. This is the local host address, and we are listening to the protocol TCP, right? So I will just remove the comments from here. So this is the configuration you need to expose the port 80 for the Kubernetes cluster. So once this is done, all you have to do is we have to create the Kubernetes the cluster using kind. So for that, I'm going to create a new file called as create kind cluster.sh. So as I'm using Mac, I'm going to create a shell script file. You can also, you can also ignore this shell script file. You can also run the commands directly inside the terminal if you're using Windows. So what I'm going to do now inside the create kind cluster is I'm going to run the command kind create cluster. I'm going to name this cluster as microservices, and I'm going to provide the config reference as config.yaml. So I think I made one mistake. I think Kubernetes expects the configuration, the file extension for YAML to be .yaml, not .yml. So let's refactor this. Let's rename this as config.yaml. All right. So now let's open the terminal, and now I have to cd into the k8s folder inside kind, and now I'm going to type the command /kind cluster.sh. It says that the permission is denied, so I have to add the permission for it. chmod x create kind cluster.sh, and now I'm going to run the create kind cluster command. So you can see that it is creating the cluster called as microservices, and it's doing all necessary startup tasks to create the cluster. So it may take some time for you. If you're doing this for first time, it will take maybe a minute or two to create the cluster. And once this is done, you can see this information like the cluster creation is successful. And so the next thing we are going to do is to create the manifest files to run our services, right? So for that, I'm going to create a new folder under the k8s folder called as manifests, and inside that I'm going to create another folder called as infrastructure. So we will first start off by creating manifest file for all the infrastructure we have. So for example, we have this Docker Compose file, and inside this Docker Compose file we have all the infrastructure like the databases, our Kafka brokers, and also the Grafana, Loki, and Tempo. So all these comes under infrastructure. So we are going to create manifest files for all these infrastructure modules all these infrastructure components first, and then we'll go and create manifest files for our application services. So the first service we are going to create the manifest file for is going to be for the infrastructure. So inside the infrastructure, so I'm going to choose MySQL as the service which I want to first create the Kubernetes manifest file. So you can see that we already have a reference of what we want to do with the Docker Compose file. So this is the Docker Compose file service, the Docker Compose service for MySQL. So we have this image name, container name, the environment variables, the ports which we are exposing, and also the volume information. So we need to create a similar setup also in Kubernetes. So for that, we need to first create a deployment. So create a deployment. So if you are not aware of what is deployment, again, I suggest you to watch an beginner level tutorial, maybe on YouTube about Kubernetes, and then come back to watching this tutorial. So we'll first create a deployment for Kubernetes. So for that, I need to first go into the folder manifest. First, I have to go back from the kind folder, and I'm going to go inside the manifest folder into the infrastructure. And here I'm going to create a deployment for MySQL service. So for that, I'm going to write a command called as kubectl create. And before we go ahead and create the deployment, you need to install also kubectl in your machine. So for that, you can refer to this install and setup kubectl page. I will link this in the description section. You can install the kubectl binary. So to create the deployment, you need to type the command kubectl create deployment, and the name of the deployment is going to be MySQL. And you can see that my system is already suggesting me the necessary parameters to run this command, but I will just ignore this for now and then type out the command for you. For the deployment for the MySQL image, I have first to create the MySQL deployment, I need to provide the reference to the image name. So for that, I need to use the the image flag, and I'm going to provide the name of the MySQL, the Docker image for MySQL, right? So this is going to be the same as the image we have defined here inside the Docker Compose file. So I'm just going to copy this and paste it here. And after that, we also need some other additional configuration, like we are exporting the port 3306. So we also need to provide this information while creating the deployment. So for that, I'm going to type in the flag -- port is going to be 3306. And we need to run the MySQL deployment using only one replica. So we can also have, of course, multiple replicas in the production environment. We'll use multiple replicas usually, but as this is a local development environment, and we have, we are working with minimal resources, because we cannot have 3 replicas for all the services, right? Because we are having more than 10 services which we want to run on our machine. So we will just, for everything, we will stick with the replicas as one. So just for now, I'm going to provide the replicas values as 1. And what I want to do now is, I don't want to create this deployment right away, but I want to create a dry run for this, because I don't want to run this deployment and then start the installation of this deployment. I just want to do a dry run, so that I want to see if this command is working or not. So for that, I can provide this dry run flag, and I provide the value as client. So if you provide the dry run value as client, what it will do is, it will try to create the deployment, but it will not send the deployment. It will not actually create the deployment in the Kubernetes server, right? It will just validate the deployment parameters, but it will not create the deployment by sending this to the Kubernetes server. So that's why we need to use client. And finally, we need to create the manifest file for the deployment. We just do because we want to reuse this, because every time we don't want to use the kubectl command. What I want to do now is, I want to create the manifest file for MySQL deployment, right? So for that, I need to first run the deployment and do the export using the -o flag in the YAML format. So this will create the deployment, and then it will export the manifest file of deployment in the YAML format. So if I just press on enter, what it is doing is, it is trying to create the deployment in the dry run client mode. That means it validates if the deployment parameters are correct or not. So once this is done, what I'm going to do now, I'm going to copy this whole YAML file, and I'm going to open the K8s folder under the manifest infrastructure. I'm going to create a new file called as mysql.yaml, right? And here I'm going to paste in this whole this whole thing as it is, and I'm going to make some small changes here. So we can see that this creation timestamp is set as null. This is not really needed for us. I'm going to remove this particular property, and also the creation timestamp is there inside the template metadata structure. I'm also going to remove this, and also the status field is not necessary. I'm going to also remove this, and also the resources, we don't need this right now. So I did a small cleanup here, and also the strategy is not needed. So we will just provide the fields which we are using, right? We don't want to provide any of the unnecessary fields right now. So these are the bare bones. So this is the bare bones deployment for MySQL. So whenever you run a MySQL deployment, so this is the manifest file that is being created in the background and then applied to the Kubernetes server. After creating the deployment, what we have to do is we have to also create a service, right? So for that, we need to, I'm going to use the same file to store all the deployment service and all the configurations. So to also store configuration for service here, what I'm going to do is I'm going to add the three lines as separator inside YAML, and I'm going to paste in also the Kubernetes manifest file for the services, MySQL services. So for that, I'm going to go back to the terminal, and this time I'm going to create kubectl create service, and the kind of service I'm going to create is going to be a cluster IP service. So I'm going to type in cluster IP, and the name of the service is going to be MySQL, And this service is being exposed on port 3306 because the deployment container is also running on port 3306. So we will also use the service on port 3306. So for that, I'm going to provide the TCP flag as 3306 followed by 3306. So this is the pair of the ports we are exposing. So we are going to make use of the 3306 port inside the container, inside the service, and we are going to map it to the 3306 port of the local machine. So if you run this service, you can access the MySQL service on the port 3306 here. And also for this, as we did for the deployment, we also want to add the dry run flag. So the dry run flag is going to be client. And finally, we're also going to export this manifest file for the service. So if I press enter, you can see that the manifest file is created for our service. So I'm just going to copy this particular manifest file and go back to the mysql.yaml file, and I'm going to simply paste this inside the YAML file. Let's also do some cleanup here. We don't need this creation timestamp, and also the status, we don't need this. The type cluster IP is also not needed because if I remove this type as cluster IP, then the default type is always cluster IP. So you don't need to specifically mention that inside the manifest file. So also I don't need to have a port specifically. So I'm just going to remove this particular property here, and I'm just going to leave the port where the Kubernetes service is exposing the port, and also the protocol which is using, it's going to be TCP, and the target port of the service is going to be 3306. So this is the configuration also for the service, and we have the configuration for deployment. So to the next thing we have to do is we have to add some environment variables to the deployment, because if you go to the Docker Compose file, you can see that we are using an environment variable called as MySQL root password. We are setting this environment variable for our Docker service. So we also need to do this for our Kubernetes deployment for MySQL. So to do that, I'm going to go to the mysql.yaml file, and under the deployment section, under the template specs containers, I'm going to add another field just below the ports field called as env, and inside this env I'm going to provide a key value pair, so with name as MySQL root password and value as MySQL. Right, I'm going to provide this as a string. So this is the same value I provided inside the Docker Compose file. All right, so you may have observed that we are configuring the sensitive MySQL root password inside the deployment itself. So this is not so nice. So what we can do here is, instead of defining the secret inside the deployment, we can create a separate component called as Kubernetes secrets, and you can reference the Kubernetes secrets from the deployment file. So to do that, I'm going to go back to the terminal one more time, and this time I'm going to type in the command Kubernetes create secret generic, and then I'm going to create the secret with the name MySQL secrets, and I'm going to create the secret with from literal. So I want to create a secret pair. So I have the option to create the secret from a file or from a property. So I'm going to create the secret from a property using from literal flag. So the name of the property is going to be MySQL root password, and the secret value is MySQL, right? So of course, as we did for all other components of Kubernetes, we are going to first do the dry run and export the YAML file. So I'm going to type enter, and you can see that this is the secret which is generated by Kubernetes for us. So what it did is it took this particular value and it is encoding it in the base64 format and then providing the value of the secret here. This practice is not really 100% foolproof, but this, as we are just doing local development for Kubernetes, we will go with this approach. But in a production grade setup, we'll use another external secret store Like if you're using AWS, you will use the AWS secret store, or maybe software like Vault, which is used to securely store secrets. So for now, we'll just make use of the Kubernetes secrets. So I'm just going to copy this particular manifest file, and I'm going to add this to the mysql.yaml file. So first I'm going to add a 3-line separator and then paste this information here. So as usual, I'm going to clean up the creation timestamp field, and we have created the secrets. Now we have to refer the deployment to this particular secret. So I can do that by removing this value field, and I can use the field called as value from, and then I can add the reference to the secret key ref property, and then the secret key ref, the key of the secret key should be MySQL root password. So you can see that is the key which you are using for the secret, and this is the value, right? So we need to provide the key for the secret, and also the name of the secret. This is going to be MySQL secrets. So if you just click on control click here, it will take this to the MySQL secrets configuration. So that means it's configured correctly, because it's the deployment is able to identify the secret and then assign it to the secret is assigned to the deployment. So this is one way of using the Kubernetes secrets. So this is one way of using Kubernetes secrets to store the secret values. And lastly, what we have to do is we have to provide also the volume information here. So you can see that whatever data which is created inside the MySQL Docker container, we are mounting it into the local folder onto the local machine under the folder data MySQL, right? So if you just expand the data in MySQL, you can see that all the metadata which is generated by the MySQL database is mounted onto this particular folder, right? So we also want to do this similar thing also in the Kubernetes world. So to do that, we have to create another component something called as persistent volume. So to create the persistent volume, unfortunately, there is no command to do that. We have to type out the manifest file ourselves. So for that, I'm just going to make use of the GitHub Copilot. So I'm going to type in API version as v1, and the kind we have to create is going to be persistent volume, and the metadata field is going to be MySQL PV. This PV stands for persistent volume. And then we also have to define the specifications here. For the specification, I'm going to provide the storage class name as standard, and the access mode is going to be read write once, and the capacity, I'm going to provide this capacity of 1 gigabyte to store the MySQL data, and the host path is going to be /data/MySQL. So just to be sure that it won't conflict with the existing storage, I'm just going to delete the data folder completely. So now when the Kubernetes deployment is running, all the data is freshly created on the host machine. So after creating a persistent volume, we also need to create a persistent volume claim. So for that, I'm just going to copy everything inside the persistent volume, and I'm going to paste this below the persistent volume, and I'm going to change the kind name as persistent volume claim, and the metadata name is going to be MySQL PVC, which stands for persistent volume claim. The storage class name is going to be standard. The access mode is going to be read write once, and here I'm going to remove these two fields which are not eligible for persistent volume claim, and I'm going to type the field called as resources, and inside here I'm going to provide the storage as 1 gigabyte. So once this is done, this is the configuration which is needed to create a persistent volume for our MySQL database. Once this is done, this is all we need to create the deployment and the manifest the configuration for our MySQL database. There is also one thing we need to do. If I go back to the Docker Compose file, you can see that we are initializing the database with some SQL commands. So if I go to Docker MySQL, we have this init.sql file where we are creating two databases, order service and the inventory service. We also need to do this in our Kubernetes manifest. So I'm going to create a config map. So to create a config map, I'm going to add another deployment another component inside the mysql.yaml file. So I've added the separator in the 3-line separator for YAML, and inside the API version I'm going to provide it as v1, and the kind is going to be of type config map, and inside that I'm going to provide the metadata with the name as MySQL initdb config, and the data, it contains the actual contents of the config map. So the data is, I'm going to call it as initdb.sql, and I'm going to add a pipe which acts as the separator, and I'm going to press enter, and in here I can type the contents of the SQL file. So I'm just going to open the init.sql file, and I'm going to copy this init.sql and paste these contents here. So you can see that whenever this config map is created, it's going to run this particular commands which are there inside the initdb.sql. So we created both the config map and also the persistent volume and persistent volume claim. So the next thing is to assign these components to our deployment, right? So of course we have to reference this to our deployment so that all of them work together. So for that I need to add some configuration under the env field. I'm going to add another configuration to define a volume mount. So this volume mount specifies the path in which all the data which is generated by this container should be mounted on this particular path, right? So the path which contains the data is defined to be should be defined under the mount path section. So the path is going to be, if I refer to the Docker Compose file, this is going to be /var lib mysql. So I'm going to go back to the deployment file and I'm going to paste this inside the mount path, and the name of the mount I'm going to provide it as MySQL data. This particular volume mount, we have to replicate it inside the host machine, right? So for that I'm going to create a volume and define it under the deployment. So I have to go back to the indentation. I'm going to, under the containers section, I'm going to type in the field called as volumes, and I'm going to create a volume with the name of MySQL data. So make sure that the name of the volume mount and the volume is matching, or else we will get an error. So I'm going to type in the volume name as MySQL data, and I'm going to define a persistent volume claim, and the claim name is going to be MySQL PVC. So this should be the same name as the MySQL persistent volume claim we have created here, or make sure that you follow the same naming convention and the exact same name. So after adding this, we have defined a volume mount in the container, and we have and we attach that volume mount to the persistent volume claim, right? So the next thing we have to do is we also have to mount the MySQL init.sql file. So init.sql file, which is there inside our config map. So what we have to do is we just have to mount this config map, and this SQL file will automatically be available to our MySQL pod, MySQL deployment. So what I'm going to do now is I'm going to scroll up, and under the volume mounts I'm going to create another mount path, and the mount path is going to be /docker entry point initdb.d. So this is the same path we have used inside the Docker Compose file, and the name is going to be MySQL initdb config. So the name of this volume mount should match the name of the config map here, which we have defined. So once this is done, we are done. We covered almost all the major components inside our inside Kubernetes. We have defined a deployment, we have defined a service, we defined a secret, a persistent volume claim, and also a config map, right? So this is all we need to create the manifest file to run MySQL. So what I'm going to do now is I'm going to open a terminal, and I'm going to make sure that you are inside the infrastructure folder where you have so if I just do ls, you can see that I'm inside the folder where you have this mysql.yaml file, and here I'm going to type in the command kubectl apply -f mysql.yaml, and I'm going to press on enter. So you can see that the deployment, it's throwing an error that the deployment MySQL is invalid, and it is referring to the volume mounts name. MySQL initdb config is not found. So let's see what is this issue here. Okay, so I understood the issue. We have created the volume mount, but we did not create a volume to attach that volume mount. So what we have to do now is I have to create a new entry here inside the volumes, and I'm going to name it as MySQL initdb config, and here I'm going to define a config map with the name as MySQL initdb config. So in this way, the deployment will understand that it has to map this particular mount path /docker entry point db.d to the config map with the name MySQL initdb config, right? So once this is done, I'm going to go back to the terminal and I'm going to run this command one more time, kubectl apply -f mysql.yaml, and you can see that as I've already run the command previously, all the components like service, secret, persistent volume, and claim are created, but the only thing which is not created is the deployment. So when I ran it for the second time, the deployment is created successfully, and all the other components are unchanged. So let's check if the deployment is successful or not. I'm going to run the command kubectl get all, and you can see that all the components which are created. So the first one is going to be the pod, which is nothing but a normal container which is managed by Kubernetes, and we have the services, the service MySQL, which is using a class type of cluster IP, and this is the IP address of our cluster, and it's running on port 3306. And we also have our Kubernetes cluster, which is running on port 443. We have our deployment for MySQL, and also the deployment consists of a replica set, which is created implicitly for us. So, and this is the replica set for our MySQL. So to check other components like secret, you can type it kubectl get secrets, and you can see that this is the MySQL secrets which is created. Let's also check if the config map is created. I'm going to type in kubectl get config map, and you can see this MySQL initdb config is the config map which is created. Likewise, let's check also the PVCs, kubectl get PVC, and you can see the MySQL PVC which is created. And lastly, let's also check if the persistent volume itself is created or not. And you can see that the persistent volume MySQL PV is created with 1 GB capacity, and it's bound to the MySQL PVC persistent volume claim. So now I'm going to check the logs of our MySQL deployment, MySQL pod. So for that, I'm going to type in kubectl get pods, and you have the name of the MySQL pod. I'm just going to select this and copy this, and I'm going to type in kubectl logs -f, and I'm going to paste in the name of the MySQL pod here. And if you press enter, you can see that our service is up and running without any issues. You can see that the service is running on port 3306. So I'm going to type on Control-C here to come back off the logs terminal. And what I'm going to do now is I'm going to access the service which is running on port 3306. I'm going to, if I type in the command kubectl get svc, you can see that we have a MySQL service which is running on 3306. What I'm going to do now is I'm going to access this service from my local system, right? So for that, what I have to do is I have to do a port forward from my local to the MySQL service. So I can do that by using kubectl port forward svc/MySQL, and I'm going to expose the port 3306 from local and map it to the 3306 port of the service. So if I press on enter, you can see that it is forwarding from our local host 3306 to the 3306 port of the MySQL service. Now to connect to the MySQL database, I'm going to make use of the internal MySQL database console from IntelliJ. You can also use, of course, other IDEs like MySQL Workbench or any other IDE you like. So to connect to the database, I'm going to click on the data source, MySQL, and here I'm going to provide the host name as localhost, the port as 3306, The username is going to be root, the password is MySQL, and I'm going to test the connection, and you can see that the connection is succeeded, and I'm going to click on apply and OK. And if I click on this particular service here, the databases, order service, and the inventory service are already created inside the cluster. So this is what we need. This means that the MySQL deployment is working fine and without any issues. Alright, so what I did now is to create the rest of the manifest files for all our infrastructure services. So as you saw how I created the service manifest files for MySQL, so that includes the deployment, the service, the secrets, persistent volume claim, and config maps. So all these workloads quite common for all the other services also, right? For example, if you take the example of MongoDB, you can see that if I scroll all the way up, we have the deployment, which is pretty similar to how the deployment is in MySQL. So if I just split this screen into two to the right side, we can quickly verify that the deployment manifest file is looking very similar to how it is in the MongoDB, right? So the only difference here is coming in the spec containers image. Here we are defining the image as MySQL 8.3.0, but here the name is MongoDB, of course, instead of MySQL, and we have the image of MongoDB. And the container port, we have 3306 in MySQL, and in MongoDB we have the default 27017 port, and we have the environment variables, and I created a separate config file here. Here the config is coming from so here we did not create any specific config for the environment variables, but here we need a config file to store the root username. So I've created the MongoDB config here. So if I just control click on here, it is taking me to the config map, which is created for MongoDB. And here you can see that inside the config map, there are two fields: Mongo initdb root username, Mongo initdb database. So these two fields are referenced inside the environment field using this config map key ref field. I am providing the key as the Mongo initdb root username and the name as the MongoDB config. So the deployment will now refer to the config through this name. So similarly, I also have the environment variable Mongo initdb root password, but this time instead of MongoDB config map, we are looking this up from the MongoDB secrets, which is a Kubernetes secret file, secret config. And here you can see that the MongoDB init root db password, Mongo initdb root password, is referenced in the deployment file. Likewise, we also have the volume mount. So inside MySQL, we are using the volume mount for the /var libmysql mount path, but here the mount path would be /data/db. This is the default path where MongoDB stores all its files. And finally, we have the persistent volume claim called as MongoDB PVC. So if I created the persistent volume claim here, and also the persistent volume MongoDB PV. And also in the host path of the persistent volume, I provided the path as /data MongoDB. So this is the place where the data will be stored. Likewise, you can go through the config files. So this is the same for Grafana, Loki, Keycloak. So we are using the same configuration here. For Keycloak, one interesting thing is previously we were reading the realm JSON file from the Docker Keycloak realm export.json. So inside the Docker Compose, we were referencing this particular JSON file. If I just scroll down, we are creating the volume and then asking Docker Compose to copy the JSON file, which is inside Docker Keycloak realms folder, into the /opt keycloak data import folder. So we are doing that through the help of config map. So if I just scroll down here, you can see that inside the volume mount, we are referencing to the Keycloak realm, and the mount path is going to be /opt keycloak data import. And inside the volumes, we have the same name, Keycloak Realm, and here we are referencing to the config map, Keycloak Realm config. And inside this Keycloak Realm config, we have this Keycloak Realm import.json, which is importing all this information of the realms. So what I did was I just pasted the whole JSON file inside the config map, so that the deployment will import this particular JSON file during the startup of the pod. So you can just go through each and every one of them. You can find the manifest files inside the GitHub repository. So just let me show you the GitHub repository. So you can find this inside the K8s folder, manifest, infra, and you can find all this manifest files. You can just go through the GitHub file and then copy each and every one and paste it into your project. So the next thing I'm going to do is to create the manifest files for our services. But before doing that, we need to make some small changes. So what are the changes? So if I go to the API gateway, source main resources, and in the application.properties, not the application.properties, but inside the logback spring.xml, you can see that we are using this URL of Loki, which is pointing to HTTP localhost 3100/Loki/API v1 push. So we have a problem here because the URL of Loki is hard coded inside the logback spring.xml file, right? So this is not only for the API gateway project, we are doing this for also all our services like inventory service, notification order, and the product service. So what we have to do now is to externalize this property. So I can do that using so what I'm going to do now, I'm going to first delete this property here, and I'm going to create a new file, new property, spring property inside the logback spring.xml file. So I can do that by just copying this line number 4 and then pasting it here, and the name of this property is going to be Loki URL, and the source is going to be Loki.url. So I want to define a property called as Loki.url inside the application.properties file. So let me scroll down here. I'm going to type in something called as Loki URL, and here by default this is going to be the localhost 3100 Loki API v1 push. But what we will do is on the deployment level, we will override this particular environment variable with the URL of Loki, right? So that's why we have to externalize this particular URL. So we will create an environment variable called Loki.url, and then we will reference this inside the logback spring.xml. Now all we have to do is reference this particular Loki URL inside the URL tag. So for that, I'm going to type in $curly braces Loki URL. So now when the application is starting up, the logback spring.xml will look up for the Loki.url property. So we have to do this for each and every service. So let's go ahead and do that. So what I'm going to do now is I'm going to just copy this whole logback spring.xml, and I'm going to apply this for inventory service first. So source main resources, logback spring.xml, and I'm going to paste it here. Next one is notification service, and I'm going to also paste it here. Next comes the order service, logback spring XML, paste it here. And finally we have the product service, source main resources, logback spring.xml, and paste it here. So now the next thing we have to do is to create this Loki.url property. So source main resources, application.properties, and then I'm going to paste this, copy this from the API gateway properties, paste it inside inventory service, notification service, order service, and finally the product service. So once this is done, now we are ready to create the manifest files, and then we will override this Loki URL. So another thing we have to do is inside the API gateway, if I open source main Java routes, and if you go to the routes class, you can see that we have also hard coded the URL of the services. So for the product service, we hard coded this URL, inside the class itself. So this is not so good. What we have to do is we want to also extract this particular service, extract this particular URL into a property. So what I'm going to do now is I'm going to create property inside source main resources application, and I'm going to call this as product.service.url equals localhost 8080. Order service URL is localhost 8081. Inventory service URL is localhost 8082. So what I'm going to do now is I'm going to reference these variables inside the routes class, right? I will do that by adding this value annotation from Spring Boot, and I'm going to call this product.service.url, and it's going to be private string product service URL. And next comes the order service URL. It's going to be private string order service URL. The last one is the inventory service URL. Let's also inject this. And once this is done, I'm going to replace all the occurrences of localhost 8080 inventory with product service URL. So this once, and here it's for the product service Swagger route. I'm going to replace it one more time. And next we have the localhost 8081. So this is going to be order service URL. So let's also replace this. And finally we have the localhost 8082. So this is going to be inventory service URL. So I'm also going to replace that. Now we don't have any hard-coded values inside our API gateway. The URLs are externalized through the properties files, and now these properties are easy to override in the deployment, Kubernetes deployment manifest files. And another last thing I want to do is I want to go open the order service, and inside the application.properties file, I want to rename the inventory.url to inventory.service.url, just because I just want to keep the naming convention similar in all the services. So for order service, it's inventory service URL, and also in the API gateway, we are using the same inventory service URL, right? So in this way, if I want to create a configuration, I can create a common configuration and inside a config map, and I can reuse that configuration across all the services. So after renaming this inventory.url to inventory.service.url, the next thing I'm going to do is I'm going to replace the occurrences of inventory.url with the inventory service URL. I can do that by pressing Ctrl+Shift+R, and I'm going to search for inventory.url, and I'm going to replace all the occurrences with inventory service URL. I'm going to click on replace all and click on replace, and that's all we need to do to ready all our services to be to create the Kubernetes manifest files. Once we made all these changes, we need to build all the services, create the Docker images, and then once the Docker images are pushed into the Docker Hub, then we can start creating the manifest files for our application services. So for that, I'm just going to click on this Maven icon, click on this goal button, and then I'm going to build all the services using the command I showed you before, which is going to be Spring Boot build image, and I'm going to provide the Docker password here. So this is my Docker password. Don't worry, I will delete this password by the time the tutorial is out, so don't try to copy this. All right, so I will be back once after the build is completed. All right, so the build is now completed. All the Docker images are built and now also pushed into the Docker Hub. So the first thing before starting the Kubernetes configuration files, we will do also the create the Docker image also for our front-end application. For that, I'm going to open the front-end project, and in here I'm going to, on the front-end root project, I'm going to create a new file, and I'm going to call this Docker file. There is no easy way to use cloud native build packs for the front-end Angular application, because on our Spring Boot backend applications we can create the Docker images through the Spring Boot Maven plugin, but here the process is not so straightforward. We need to install some libraries, but instead of that, it's easier to create the Docker file and get on with it. So the first thing I'm going to do inside the Docker file is to build the Angular application. For that we need a base image. So I'm going to type in from node 22 as build. So this is going to be, the base image is going to be from node version 22. And the next step is going to be, I'm going to create a work directory called as /app. So this is the directory in which we will store all the Angular application source code, and this is going to be our work directory, right? So here what I'm going to do now is I'm going to copy the package package star.json into the work directory. So I'm going to copy the package.json, also add the package log.json file into the work directory, and after that I'm going to run npm install. After running npm install, I'm going to copy the whole source directory of front-end Angular, the whole directory, working directory, into the working directory of the Docker container. So I'm going to copy the whole source code into the work directory of app package. So after doing that, now I'm going to run the npm build. So by running the command npm run build, the Angular build will be triggered and all the distribution files will be created. Just as you see here, we have this distribution folder will be created, and all the distribution file are inside the browser. And after that, we have our step 2. In the stage 1 is completed here, where we are copying the source code, installing the application, and then building the application. The next step is to serve the application with the Nginx server. So for that, I'm going to use Nginx Alpine version. And from Nginx Alpine, what I'm going to do now is I'm going to copy from build /app dist frontend browser, and I'm going to copy it to user share nginx /html. So what I'm doing here is I'm creating a base image from Nginx, and inside the Nginx container, I'm going to copy the dist folder as it is, the dist browser folder, and I'm going to paste this inside the user share nginx HTML folder. So Nginx will serve all the files which are under the HTML folder. So when we copy everything inside this particular folder, when Nginx is starting up, it will automatically pick up and serve our Angular application. So that's what we are doing as part of this step. There is one more thing we have to do after creating this Docker file. We need to also create a Docker ignore file, because when we are copying the source code from this present directory to the work directory of the container, it will also copy the dist and the node modules and the .angular files, right? These should not be copied because these are auto-generated when we run npm install and npm run build. So that's why we need to ignore these three directories, right? So for that, I'm going to create a new file called as .dockerignore, and here I'm going to add the folders .angular, dist, node modules. So after adding these particular files to the Docker ignore, Docker will ignore these directories and then copy the rest of the directories into the working app directory. So once this is done, let's open a terminal, and I'm going to build this. Make sure that you are under the front end folder, and inside the front end folder, I'm going to type in docker build -t frontend dot. So it will build the Docker image with the tag of front end, and the context is going to be the present active folder. So when I press enter, so this is going to first run npm install, and after that it's now running the npm build command. And once this is done, the Docker build is completed. The next step is to tag this particular image. So by typing docker tag, the name of the image is going to be frontend with the tag is latest, and I'm going to tag this with my username of the Docker Hub account. So I'm typing my username. You can also type your username as it is, which is how it is in the Docker Hub account. So my username is Sayupadhyayula and frontend latest. So after adding this tag, now I'm going to push this particular front-end image to the Docker Hub repository. So I'm going to do that by docker push front-end latest, and this is going to push the image into the Docker Hub. And if I open the Docker Hub, let me show you, and you can see that the front-end image is pushed less than a minute ago. That's good. So let's go back to the IDE, and now we are ready with all the Docker images of our services, starting from the front end up till the API gateway, inventory service, notification service, order, and the product service. So the next thing is creating the manifest file for our applications. So I'm going to expand this K8s folder under the manifest. I'm going to create a new directory called as applications. And inside this applications directory, I'm going to go ahead and create all the manifest files. Again, you can refer them from the GitHub project. You can go to the applications folder and you can copy all these manifest files into your project. And once this is done, we'll start the next step, right? So make sure to do all this stuff and come back to the tutorial. All right, so I've created all the manifest files for all our services. So the first one is the API gateway manifest file. And here you can see that we have almost the same deployment configuration as the rest of the services. We have the environment variable, Spring Security, Auth2, Resource, JWT, Issuer, URI, and we have created a config map called as API gateway config and referencing this particular environment variable. And we are providing the URL of the Keycloak service here. Notice that we are providing the service name of the Kubernetes service Keycloak. So instead of just providing the name as Keycloak, I'm providing the fully qualified domain name of the service. So you need to add this to enable the service to service communication. So this is really important. You cannot just put the host name here. You need to add the fully qualified domain name of the service. This is also one important thing that we are not using. One important thing that Kubernetes has inbuilt service discovery. So when you use the fully qualified domain name, also called as FQDN, Kubernetes will do a service discovery mechanism, and it will discover the Keycloak service, and it will enable the communication between the API gateway service and the Keycloak service automatically. So that's why many of you asked why we are not using Eureka inside this project, because as we are using Kubernetes and Kubernetes has inbuilt service discovery mechanism, we are not using Eureka specifically. In the same way, we have the inventory service. There we have created also the Spring Data Source URL here. Likewise, in the notification service, we have the Spring Kafka consumer properties, registry URL property. And you can observe that there are many properties which are common across all the services, right? For example, the Loki URL, the Zipkin URL, etc. So for that, I have created a common config map called as commonconfig.yaml file. And in there, I created all the common properties which are common for all the services. The first one is the Loki URL. I provided the URL of the Loki fully qualified domain name, name of the Loki service. Likewise, we have to provide the management Zipkin tracing endpoint. So this is the endpoint which each service will call to send the traces from our services to the Tempo service. So there we have provided the URL of Tempo. And finally, we have the product service, order service, and the inventory service URL with their fully qualified domain name of the services. And lastly, we also have the Spring Boot Kafka Bootstrap servers there, and there the URL is going to be the domain name of the broker service at port 29092. So this is the common config map. And the next thing we are going to look at is the front end manifest file, the name of a front end, and it's going to reference to the front end image, and the container port is going to be 4200. And we are going to create a service with port 4200, and also the target port is going to be 4200. So this service is going to be cluster IP service as similar to all the other services we are creating. The first thing now I'm going to do is I'm going to go back to the K8s folder under the manifest. So what I'm going to do now is I'm going to apply start the deployment of all the infrastructure services first. So I'm going to type in kubectl apply -f infrastructure. So what this will do is it will scan for the YAML files, Kubernetes manifest YAML files under this folder, and it's going to apply all the folders at once, right? So I'm going to press on enter, and you can see that these are config files are created. So if I say Kubernetes get pods, you can see that all the services are up and running now. You can see this as running on my machine because I've already started this these pods just before starting the tutorial. But when you're running this Kubernetes apply command for the first time, it will take a lot of time for you to start the pods and change it to the running status. The containers, the pods can be in the status container creating, because the Kubernetes cluster should download each and every image, and then it should load this image and start the container, right? So that is, of course, is going to take some time. And after applying this after running this kubectl apply command, just give it this minute or two so that all the Docker files or Docker images are downloaded, and then the Docker containers will be started slowly, and then it will be in the running state. So you may face some issues with your Docker configuration. So what I meant by is, if I open the Docker dashboard and if I click on the settings on the top right side corner, can go to the resources section. So I am using a virtual disk limit of 120 GB. I think by default it will be somewhere around 16 or 8 GB. If you don't have enough virtual disk limit, the containers will not start up. So make sure that you use some higher disk limit, virtual disk limit. So after increasing this to maybe 120 GB, you may have to restart the Docker desktop engine. And once this is done, your pods and all the services should be up and running without any issues. So you can see that I can refresh this, and you can see that all the pods are running. I don't see any errors, which is good. I can also check whether the services are created or not. I'm going to type in kubectl get service, and you can see that these are the services which are available for us. So let's check if we are able to access Keycloak or not. So what I'm going to do now is to access Keycloak at port 8080. We cannot just go to localhost 8080 because as this is a cluster IP, we cannot access the Keycloak directly. We need to do a port forwarding, right? So I'm going to open a new tab here, and I'm going to type in kubectl port forward svc/keycloak 8080. Right. So what this is going to do is it's going to port forward all the requests coming onto localhost 8080 to the service Keycloak, which is running on port 8080. So if I just press enter, you can see that the requests are forwarded from localhost 8080 to the container 8080. And if I open localhost 8080, you can see the Keycloak administration URL, and I'm going to log into this admin portal using the credentials admin, and you can see that I'm able to log in successfully. And if I click on the realm, you can see that the Spring Microservices security realm is created automatically for us. That is great. And if I click on the clients, you can see the Angular client as well as the Spring Cloud client ID. That is also good. So I'm going to click on the Spring Cloud client ID. I'm going to create credentials. I'm going to regenerate the credentials just so that the credentials are reset and working correctly. And I'm going to go to the realm settings and click on login and click on this user registration as on, so that the user registration field will be activated. Once this is done, now I'm going to go back to the other part of the terminal, and now I'm going to start the Kubernetes config file deployment for the application services. So for that, I'm going to type in kubectl apply -f applications. So this will start the deployment of all the application services. Now I can type in kubectl get pods, and you can see that this is the message you will see if the Kubernetes cluster is pulling the messages. You will see the status as container creating. It will take some time to load the Docker images. And if I try to get the pod information one more time, you can see that the images are downloaded successfully. And now let's go to the API gateway pod. Let's copy this pod name, and I'm going to type it kubectl logs -f API gateway. And you can see that the logs, the application, the API gateway application is started without any issues. That's great. Let's go and get the pod information one more time. Let's check if the product service, let's check if the notification service is up and running correctly or not. So I'm going to type in kubectl logs -f notification service. So it looks like there is also no errors inside the notification service. That's also great. And kubectl get pods. Finally, let's check if the front end is also working or not. I'm going to copy kubectl logs -f front end, and you can see there are also no errors. So I'm going to come out of the console, and the first thing we are going to do now is I want to access the front end on port 4200. So to access front end on port 4200, I need to create a port forward from my local host to the 4200 post of the front end service. So I'm going to create a new terminal here, and I'm going to type in kubectl port forward svc/frontend, and I'm going to forward 4200 with the 4200 of the port. And also the port forwarding is now working. Let's open a new browser, and I'm going to type in localhost 4200, and we are getting a connection refused error. Alright, so I figured out the error. So as Nginx is running by default on port 80, we are using the port 4200 for the front-end application, which is wrong. So what I did was I changed the container port to 80 for the front end from 4200. And when I restarted the service, and I'm now forwarding the port for front-end service from the localhost 4200 to the localhost to the port 80 of the front-end service. So now I'm able to access the application on localhost 4200. So, and if let's click on login and see what's happening. And now let's click on login and see what's happening. And you can see that nothing is happening here. So let's go ahead and inspect the logs here in the developer console. And you can see that we are getting an error. If I go to the network tab, if I click on login, you can see that we are getting a connection refused error. That is because our auth configuration is referring to localhost 8181. The key cloak is not running on port 8181 on localhost, but it is running on a different service, right? So what we have to do now is we have to update the auth config of the front-end service. So I'm going to open the IDE now, and let's open the front-end project, and let's go to source app config auth config.ts, and in the authority URL I'm going to replace the localhost 8181 with keycloak.default default svc cluster local 8080. So because this is the URL where we are running keycloak service, so to apply these changes, I'm going to first stop this port forwarding, and I'm going to go back to the front end folder. I'm going to cd into front end, and now I'm going to build the Docker image one more time. So once the Docker build is completed, I'm going to type docker tag front end latest, and I'm going to tag this particular image again. And once this is done, I'm going to push this to the Docker Hub. So once this is done, I'm going to delete the existing deployment of the front end. So for that, I'm going to go back to the K8 folder, manifest, applications, And here I'm going to type in kubectl delete -f frontend.yaml. So that will delete the deployment as well as the service for the front-end application. And I'm going to type in again kubectl apply -f frontend.yaml. So what this will do now is it will freshly download the Docker image one more time, and it will start the deployment of our front-end application. So I can type in kubectl get pods, and you can see that the front end is now up and running again. That's good. Now I'm going to type in kubectl port forward service frontend localhost 4200 to 80. Now this is done. What I'm going to do now again is I'm going to create a new tab, and here I'm going to port forward for the API gateway, because we need to have communication with the API gateway as well. So I'm going to type in kubectl port forward svc / API gateway 9000. And lastly, we will also create a kubectl port forward for Grafana to test if the Grafana logs, the logs, traces and monitoring is working or not. So for that, I'm going to create a new tab, and I'm going to type in kubectl port forward svc / Grafana on port 3000. So let's go ahead and start our testing. So first of all, I'm going to click on login here. So I'm going to refresh the application. So if you are, so make sure, so after the deployment, make sure to long press on the refresh button, and you can see this normal reload and hard reload. So what I'm going to do now, I'm going to click on empty cache and do the hard reload. So this will delete the old JavaScript files, and it will fetch it newly from the Docker container. So now I'm going to click on login, and this will redirect to our Keycloak default svc cluster.local 8080. So this will only work if you have updated your etc host information with the Keycloak default svc cluster local. So what I meant by that is, I will show you. I'm going to open a new terminal, and I'm going to open vi/etc/host, and you can see that I've added an entry which is pointing the domain of Keycloak default svc cluster local to my local host. So whenever the browser is looking at this particular domain name, it is looking at the DNS entry inside the etc host file. So after adding this particular entry, our browser will automatically recognize that it should take this domain name and it should forward it to the local host, as we already have the port forwarding active for this particular Keycloak instance. Now it's able to, that's why it is able to forward to the Keycloak admin console. I have to first register for the new user. So I'm going to call this user as test user. Password is going to be test user. Again, I'm going to confirm this password. Email is testuser@gmail.com. First name is test, last name is user. Click on register. So now the user is logged in successfully. So now what I'm going to do is I'm going to create a new product. So I'm going to click on new product, and I'm going to type in iPhone_15 as the SKU code. The name is going to be iPhone 15. The description is iPhone 15. The price is 1000, and I'm going to click on add product, and you can see that the product is created successfully. This is the result coming in from our API gateway. And let's click on the Spring Boot microservices shop URL here, and this is getting the products from the product service. That's good. So now what I'm going to do now is add the quantity as 1 and click on order now, and it will take some time, and then you can see the message order placed successfully. So now let's check if the email, we have received an email or not in our Mailtrap mailbox. I'm going to search for Mailtrap, and inside the demo inbox, I can see that a few seconds ago, I received an email. Your order with order number is now placed successfully, right? So that means all our services, API gateway, product service, order service, and the inventory service, and last the notification service, are working as expected. So the last thing I have to do now is to check if the Grafana dashboards are working or not. So I'm going to open localhost 3000, and this is the URL portal of Grafana, and here onto the top right side corner under the toggle menu, I'm going to click on explore here, and you can see that it is already showing us all the traces inside tempo. And now let's go to Loki here, and inside the Loki I'm going to select the label as application. Inside the value I'm going to select the value as API gateway and click on run query, and you can see that we can see the logs. That's great. And if I go to the tempo, I can also see the trace information here. If I run the query, you can see that I can see all the traces information. That's also good. If I go to Prometheus, I can also see the Prometheus metrics. So here I have to select the application label and also the inventory service. If I click on run service, you can see these are the Prometheus results which are scraped from our service. And one thing I forgot to mention is inside the Prometheus configuration, you need to make one small change, because in the previous observability part, what I showed you is in the prometheus.yaml file, we are in the scrape config, we are providing the target as host.docker.internal and the port as 9000. But here there is no need to do that. I'm going to open the K8's infrastructure and prometheus.yaml, and here you can see that I'm providing directly the fully qualified domain name of the service itself followed by the port. So in this way there is no need to refer to the host.docker.internal. The Prometheus can directly access the service name of the API gateway and all other services. So that's why you can also see that it's able to provide you the name of the service as it is. And lastly, we have to also check the Grafana dashboards. So I'm going to click on dashboards, and as this is a new installation, I have to import the Grafana dashboard one more time here. I'm going to click on new, I'm going to click on import, and here I'm going to import the dashboard JSON file. So I'm going to copy this from the Docker folder under Grafana dashboard.json. I'm going to copy this and I'm going to paste this inside the import via panel, and I'm going to click on load. Right, the name is going to be Spring Boot Statistics. The Prometheus data source, if I click on the drop down, it can see that it's already referring to the Prometheus data source, which we have configured through the config map. So I'm going to select this Prometheus data source and I'm going to click on import, and you can see that the Prometheus data source is already reflecting inside the Grafana dashboard. And if I click on the instance, you can see that we have API gateway instance, inventory service, notification service, order service, and the product service. So you can see that the notification service is up from 19 minutes. It's using 3.5% of the heap memory. The CPU usage you can see here. Likewise, we have the order service. It's running from 19 minutes. The inventory service is also running from 19 minutes, and the product service also we are able to see the statistics here, and also the API gateway, we are also able to see the statistics. So I hope you are able to learn something from this tutorial series. It's been a long series, I have to admit, and I hope this is helpful for you, and I will see you in the next video. And until then, happy coding, take care.